There is something happening in the nests in your yard this spring that most people find genuinely difficult to watch once they understand it. A parent bird arrives at the nest with food. 4 chicks are calling, begging, reaching up with open mouths, producing the maximum noise and movement they are capable of. And the parent looks at one of them, then feeds a different one. It happens again on the next visit, and the next, the same chick reaching. The same chick passed over. While the others eat, this one gets weaker, smaller, slower to respond. And one day, that chick is no longer in the nest at all. The parent removed it. Most people who discover a baby bird on the ground beneath a nest assume something went wrong. The wind knocked it out. A predator disturbed the nest. An accident of some kind. The possibility that the parent put it there deliberately, that the same bird that built the nest, incubated the eggs, and fed those chicks for days, made a calculated decision to remove one of them, is something most people find almost impossible to accept. But it happens regularly, in nests across your neighborhood every spring. And the reason behind it is one of the most revealing windows into how bird reproduction actually works under pressure. Welcome to Bird Minds. Today we are going into exactly why birds sometimes reject one chick in the nest, what they appear to be detecting that you cannot see, what drives the decision, and what it tells you about the extraordinary calculations happening in every nest this season. Stay until the end, because the final section reframes this behavior in a way that changes how you see every nest you will ever look at again. To understand why a parent bird would reject one of its own chicks, you first have to understand what the nest actually is from the bird's perspective. Most people see a nest as a cradle, a safe place where young birds grow until they are ready to fly, something inherently gentle and protected. From the parent bird's perspective, the nest is a resource allocation problem. Every trip to the nest costs energy. Every caterpillar, every insect, every food item delivered represents time spent foraging, time spent flying, time spent exposed to predators. A breeding season is a finite window, a specific number of weeks in which the parent must convert available food resources into surviving offspring before the season closes. The question the parent is continuously answering is not how can I keep all of these chicks alive? It is how can I produce the maximum number of healthy fledglings given the actual resources available to me right now? Those are not the same question, and the difference between them is where the rejection behavior begins. The setup for chick rejection often starts before the chicks even hatch. Birds do not lay all their eggs simultaneously. They lay 1 egg per day over a period of several days. But in most species, incubation does not begin until the clutch is complete, which means all eggs hatch within a relatively short window of each other. In some species, however, raptors, herons, owls, and certain songbirds, incubation begins with the first egg, which means the first egg hatches before the last one is even laid. By the time the youngest chick emerges, its oldest sibling may already be several days old, several days larger, several days stronger, several days more experienced at competing for food. This is called asynchronous hatching, and researchers who have studied it extensively found that it is not accidental. It is a reproductive strategy. By creating a size hierarchy within the nest from the moment of hatching, the parent establishes a built-in buffer. In good years, when food is abundant, when both parents are healthy, when the weather cooperates, the youngest, smallest chick survives alongside its larger siblings. The buffer was not needed, and all chicks fledged successfully. In difficult years, when food becomes scarce, when a parent is injured, when an unexpected cold snap reduces insect availability, the smallest chick loses the competition for food delivery first. It weakens fastest, and the resources that would have gone to keeping it alive are redirected to the stronger siblings who have a better chance of surviving to fledgling. The youngest chick is not necessarily a mistake. In many species, it functions as biological insurance, a chick the parent produced in case conditions were good enough to support it, and a chick whose absence, when conditions fall short, allows the rest of the brood to survive. But asynchronous hatching explains the setup. It does not fully explain the active rejection behavior, the parent arriving at the nest with food and consistently not feeding a specific chick. That requires a different explanation, and that explanation comes down to what parents appear to be reading in their chicks on every single visit. When a chick begs for food, it is not just making noise, it is producing a signal. The intensity of the begging call, the vigor of the reaching movement, the color and brightness of the gape, the open mouth interior that communicates its current physiological state to the parent. A healthy, well-fed chick produces a vigorous, loud, brightly colored signal. A chick that is weakening, whether from losing food competition, from illness, from a developmental problem, produces a less intense version of that same signal. The begging becomes quieter. The movement becomes less vigorous. The gape coloration changes in in ways associated with compromised condition. Researchers studying food allocation in wild bird nests found that parent birds directed food preferentially toward the chicks producing the most vigorous begging signals, which are generally the chicks in the best physiological condition to survive. This means the chick receiving the least food is the chick producing the weakest signal, which is the chick that is already weakest, which means it receives less food and weakens further. The process is self-reinforcing, and it appears to be driven not by the parent choosing a favorite, but by the parent responding to a signal that indicates where food delivery is most likely to produce a surviving fledgling. The rejection is not emotional, it is informational. The parent appears to be following signals the chicks themselves are producing with every begging call. There's a second driver of chick rejection that operates on completely different logic, and this one involves a detection ability in parent birds that most people find genuinely surprising. Research suggests that parent birds can detect signs of illness or developmental compromise in their chicks through subtle behavioral and possibly chemical signals, cues that healthy chicks do not produce in the same way. Researchers studying nest sanitation behavior, the instinct parent birds have to remove fecal sacs and dead material from the nest, found that parents sometimes extend this removal behavior to chicks showing signs of serious illness or developmental failure. The behavior does not appear to be directed aggression toward the chick. It more closely resembles the same nest maintenance instinct applied to something the parent's sensory system has registered as a concern for the nest's overall health. A seriously ill chick in a nest is not just a chick that may not survive. It is a potential source of pathogens in an enclosed space where healthy chicks are in constant close contact. Removing it may protect the investment represented by the remaining brood. This is one of the hardest aspects of bird reproduction to sit with from a human perspective, but from the parent bird's position, operating within a breeding season that represents months of work in a nest that represents everything, the behavior that protects the surviving chicks is the same protective instinct that drives every other parenting behavior in its repertoire. Applied to a situation where protecting some appears to require letting go of one. There's a third cause of apparent chick rejection that does not involve the parent's own offspring at all: brood parasitism. The brown-headed cowbird does not build a nest or raise its own young. It locates active nests of other species, waits until the host parent is absent, enters the nest, removes a host egg, and lays its own egg in its place. The cowbird egg typically hatches ahead of the host's eggs. The cowbird chick grows faster, demands more food, and in many cases actively outcompetes host chicks for food delivery, not through deliberate aggression, but through the sheer intensity of its begging signals and its physical advantage in size. The host parent continues feeding this chick that is not its own, responding to the strongest begging signal in the nest, which belongs to the cowbird. The host's own chicks, unable to compete with a species that evolved specifically to dominate whatever nest it occupies, may receive insufficient food and fail to survive. What looks like a parent rejecting its own chicks in these cases is often something more complicated: a nest where the competitive dynamics have been fundamentally disrupted by a species that has been refining this strategy across millions of years. Some host species have developed defenses. American robins recognize and eject cowbird eggs with relatively high accuracy, but many smaller songbird species have not yet developed effective rejection responses, and in their nests, the dynamic reverses entirely. The cowbird chick is not the one being rejected. It is the one doing the outcompeting. So here is what is actually happening in the nests in your yard this spring. Every chick in every nest is continuously producing signals that communicate its condition to the parent on every visit: the vigor of its begging call, the brightness of its gape, the intensity of its reaching movement. Research suggests parents are reading those signals and allocating food in ways that appear to favor the chicks whose condition indicates the best likelihood of survival given the resources currently available. This is not favoritism. It is the parent responding to the information available to it, doing the only thing that appears to maximize the number of healthy birds that will eventually leave that nest. In good years, every chick produces strong signals and every chick fledges. The youngest, the insurance chick, survives alongside its siblings, and the parent's full reproductive investment is realized. In difficult years, the signals diverge. Resources concentrate toward the chicks whose condition signals the strongest survival probability. The brood shrinks to match what the environment can actually support, and the parent continues working harder now with a smaller brood to bring the remaining chicks to the moment of first flight. Every fledgling you see this summer, every young bird taking its first uncertain flights through your yard, still following a parent that brings it food while it learns, arrived at that moment because of decisions made in the nest that were far more complex and far more costly than they appeared from the outside. The nest is not a peaceful cradle. It is where some of the most consequential decisions in a bird's life get made, under pressure, with limited resources, in a window of time that does not stay open. And the parent making those decisions is doing everything it can, with everything it has, for the chicks that still have the greatest chance of reaching their first flight. Tell me in the comments, have you ever watched a nest closely enough to notice something you could not explain? A chick that seemed to disappear, a parent that seemed to return less often to one chick than the others. I want to hear what you saw. I read every single one. I will see you in the next one.